All right, let's dive right into this cluster. We can read the title up here. It says Osteoporosis, Bones Building. So we already know that osteoporosis has something to do with bones. So what I'm going to do is read the thing in its entirety, the full paragraph. I'm going to do some annotations as I go, and at the end I'll pause, finish annotating, and show you guys what I come up with. Bone is not a static structure. It is living tissue, constantly being broken down and rebuilt through the coordinated actions of two types of cells: osteoclasts, which break down bone and release calcium into the blood, and osteoblasts, which build new bone. These processes, together referred to as bone remodeling, are regulated by feedback involving hormones, such as parathyroid hormone, PTH, and calcitonin, to keep blood calcium levels stable. Homeostasis is maintained in the skeletal system by osteoclasts and osteoblasts, maintaining the right level of calcium in the blood and the right density in the bones. When this feedback is disrupted, such as when estrogen levels decline during aging, bone resorption may occur faster than bone formation. Over time, bone density decreases, leading to osteoporosis, a disease that makes bones fragile and more likely to fracture. This condition illustrates what happens when the body fails to maintain homeostasis in the skeletal system. Okay, so here I have my fully annotated paragraph. So I annotated that I differentiated between the clasts and the blasts. I left off the osteo part because they both start with the same part. I wanted to highlight that difference is really that one letter. Osteoclasts break bones down. Osteoblasts rebuild bones. I also highlighted this word, hormones, and I told myself that means we're talking about the endocrine system. I also want to add that bones up here and throughout the entire reading really tells me we're talking about the skeletal system. And then over here, I just wrote that bone remodeling refers to osteoblasts and clasts balancing calcium levels and bone density levels. So I wanted to note to myself those two things that we're balancing. As we said, we're talking about homeostasis here, so we're talking about balance. I'm gonna write that too, actually. Balance. And then down here, I kind of simplified this last bit here. I said, aging leads to a decrease in estrogen, which leads to osteoporosis, which equals fragile bones or low bone density. So you guys can see here, I'm using these symbols so I don't have to write that full sentence. I'm saying aging, using this arrow to say, leads to a decrease in estrogen, which leads to osteoporosis, which means fragile bones and low bone density. So we want you guys to be using those symbols too to simplify your notes for yourself, make things quicker. All right, down here we have two models that the text is providing us. So it says osteoblasts and osteoclasts. It's showing us a cross section of a femur. That is a leg bone. And it's telling us osteoblasts form new bone tissue and osteoclasts break down old bone tissue. We already know this. This is kind of just reinforcing what the reading told us. And then over here, it's telling us stages of osteoporosis, which I'm going to remind us means fragile bones / low bone density. Okay, so normal here. And then we have something called osteopenia. I guess that's like an in-between stage. Osteoporosis and then severe osteoporosis. So you can see as we go, the bone density is getting less and less. So we're down here to our first question. Which statement best describes how bone remodeling normally maintains homeostasis? I'm going to just bring us back up to the reading where we said that bone remodeling is osteoblasts and class balancing calcium levels and bone density. So I'm going to look for an option that reads like that. Osteoblasts and osteoclasts alternate activity to keep the amount of calcium in bones constant. Bone resorption and bone formation occur in balance. I like that word. Regulated by feedback hormones. Okay, I'm liking this one because it's telling us both the resorption and formation, like we said in our annotation. It's talking about balance and it's talking about hormones, which we know are involved. I'm going to keep reading to make sure there's not a better answer. Osteoblasts release calcium into the blood whenever bones become weak. Okay, so we know it said osteoblasts form new bone tissue. So that one is not right. That's describing what clasts do. Hormones prevent any change in bone mass throughout an individual's life. No, that is not what hormones do. Okay, so I'm going to go ahead and say 2 here. When a person's blood calcium levels drop below normal, which response helps restore homeostasis? Okay, so we're looking for which one releases calcium into the blood. So blasts are making new bone and clasts are breaking down old bone, which releases calcium into the blood. Yeah, osteoclasts, which break down bone and release calcium into the blood. So we're looking for the answer that says osteoclasts are doing this job. Okay. Increased release of calcitonin to build more bone? No. Decreased activity to osteoclasts? No. Increased release of parathyroid hormone to increase bone breakdown? Maybe. Decreased release of parathyroid hormone to prevent calcium release? No, we don't want to prevent calcium release. All right, so we have option 3. Now, option 3 does not mention osteoclasts, which was the thing we were looking for, but it's telling us increase bone breakdown, which is the job of the osteoclast that we were looking for. This option 2 was trying to throw you off because it included the right word, osteoclast, but it's saying it wants to decrease activity of osteoclasts, so that is not right. So 3 is our right answer here. Okay, and then question A, that's telling us that this is an open response, is asking us, explain how the disruption of communication between organ systems can lead to the development of osteoporosis. Okay, so there are a few pieces of information we need to pull from the text here. Okay, so those 2 pieces of information are going to be what organ systems are involved and what is the cause of osteoporosis. So let's zoom back up to our annotation. Immediately, skeletal system, endocrine system, and then the cause of osteoporosis. We see this note down here saying what leads to osteoporosis is a decrease in estrogen. Estrogen is a hormone. It said that in the text, so we know that, and so that relates to the endocrine system. So we see a decrease in estrogen from the endocrine system caused lower bone density in the skeletal system. So that's what we need to explain here, is how the disruption of communication between these 2 organ systems leads to the development of osteoporosis. Now, the last thing we need to remember is that this is telling us to explain how, which means we need to tell the steps or show a line of events that show how this happens. Here we have our complete answer. It says, in normally functioning bodies, the endocrine system uses hormones like estrogen to communicate with the skeletal system when bone density needs to increase. As people age, this communication is disrupted as estrogen levels decrease. when these hormone levels decrease, the endocrine system is no longer able to communicate with the skeletal system, leading to low bone density and diseases like osteoporosis. This response includes all pieces that the question asked for. It includes the organ systems and the cause of osteoporosis, and it explains how these two things are related. That is a good answer. Okay, so the section up here I've already annotated. It says menopause leads to decreased estrogen, which we know from the previous text leads to low bone density. And then it has two terms for us here, premenopausal and postmenopausal. Pre, of course, meaning before menopause, so they haven't started menopause yet. They still have high estrogen. And postmenopausal means they're in menopause, so they have decreased estrogen. Okay, then we come down to the table down here, and we have pre and postmenopausal women, average bone density, and average estrogen levels. So we can see for the premenopausal women, they have higher bone density and higher estrogen. Postmenopausal women, lower bone density, lower estrogen. All right, so our first question, which claim is best supported by the data? We just summarized the data up here, so we're just looking for a claim that matches what we just said here. So 1, estrogen has no effect on calcium levels in the blood. Okay, we know that calcium levels are also balanced by the same hormones that balance the bone density. So it doesn't make sense to say that estrogen affects bone density but doesn't affect calcium. No. Lower estrogen levels are associated with reduced bone density. Lower estrogen, reduced bone density. That checks out. That's what's happening in postmenopausal women. Lower estrogen, reduced bone density. So we're going to keep 2 as a good option, but we're going to keep going to see if there's an even better option. Higher estrogen levels caused increased osteoclast activity. If I was holding a real paper, I would flip over to the front and remember that osteoclast with the C means that we are breaking down bones. So that would mean that we would have lower bone density. Now, up here, higher estrogen is higher bone density. So that's not right, that's opposite. Bone density remains stable regardless of hormone levels. Estrogen is a hormone, and as it changes, bone densities also change. So no, it does not remain stable. 4 is wrong. 2 is the correct option here. All right, question B. Again, it's a letter that means open response. So it says, complete the model to show the normal response to stimulus shown and the response of someone with osteoporosis. So we're going to be comparing a normal response to the response of someone with osteoporosis. All right, we're going to come over here to our model. And this top section is about the normal response. Bottom section is about response with osteoporosis. So let's focus first on the normal. If someone has lower bone density, their body needs to respond to bring that back to normal, bring it back to homeostasis. So if we flip back over to the front page, we can remember, okay, so that response will be that hormones are released to trigger osteoblast activity to build bone. That's the normal response in somebody without osteoporosis. Now, if we come down to the response with osteoporosis, that means that there's not enough hormone activity, whether it's estrogen or another necessary hormone. There's not enough hormone activity to stimulate osteoblasts, so bone density remains low. All right, question C. A drug is developed that decreases osteoclast activity, but also interferes with calcium release from bone, of course. Evaluate one potential benefit and one potential risk. So in order to answer this question, we need 2 pieces of information. All right, we need to know what do osteoclasts do, and we need to know about how calcium levels are balanced. You guys would flip back to that paragraph on the front page that tells you about osteoclasts and blasts and calcium levels and all that. And you would remember that osteoclasts break down bone, and release calcium into the blood. So one potential benefit would be increasing bone density, and then the drawback would be an inability to regulate calcium levels. Osteoclasts both decrease bone density and increase calcium levels. So if we're decreasing their activity overall, these would be the benefit and drawback. You guys would have to write that in a complete sentence, but here I'm just highlighting the key pieces you would need to include. All right, and then we come to this reading. When muscles contract during exercise, they require large amounts of ATP. Immediately I'm writing GOWAC. We're talking about ATP. We are going to write GOWAC in case we need to discuss cellular respiration. Okay. To meet this energy demand, systems in the body increase oxygen delivery to muscle cells. Okay, we're definitely talking about cellular respiration now. We're talking about muscle cells. We're talking about oxygen delivery. We're talking about ATP. The increase in muscle contraction also stimulates osteoblasts in the skeletal system to build new bone. Okay. Regular exercise, therefore, supports homeostasis by maintaining both energy balance and bone density. However, when oxygen levels are low or energy production is insufficient, bone building processes may slow, contributing to diseases such as osteoporosis. All right, I made this little flow chart over here. It says when exercise is happening, that leads to muscles contracting, which leads to two things. One is higher ATP and higher oxygen delivery, and two is higher osteoblasts and higher bone density. Now, we are talking about increasing oxygen delivery. I know this relates to two organ systems. I'm going to write it here. This relates to the respiratory system and the circulatory system. Of course, we know the respiratory system is bringing in oxygen, and then the circulatory system is transporting that oxygen throughout the body. We're also talking about muscle cells, so this also relates to the muscular system. So then down at the bottom, it says when oxygen levels are low or energy is inefficient, bone building slows. So that's basically the same thing as what we said over here, just in reverse. So lower ATP production obviously means lower oxygen, and lower bone density is what it leads to here. All right, so our question here says, which statement best explains how exercise helps maintain homeostasis in the skeletal system? We just summarized that really clearly with our annotations, so now we're just looking for an answer that matches what we said. Exercise decreases the need for oxygen. Immediately no. Exercise does not decrease the need for oxygen. We need more oxygen the more that exercise is happening because we're doing cellular respiration. Exercise increases bone breakdown by osteoclasts to release. Nope. Exercise, we said over here, increases osteoblasts, not osteoclasts. 3. Exercise strengthens bones by stimulating osteoblast activity through mechanical stress. Okay, that's true. We're going to read the last one to make sure. Exercise reduces ATP use. No, it's definitely 3. The other 3 were super wrong, and option 3 really matches what we annotated for. All right, moving right along to this last page here, we're going to read this multiple choice question. During exercise, muscle cells increase their rate of cellular respiration. Now, cellular respiration has officially been mentioned here now, but we already knew this was about cellular respiration because we saw all the clues in that paragraph before. So, which system interaction allows this increase? Again, we've already highlighted which systems are involved in our annotations before, so at this point, we're just looking for the option that matches what we already said. The digestive system provides mechanical stress to muscles. No. The respiratory and circulatory systems deliver more oxygen to cells. Yes, but we're going to keep reading to make sure. The endocrine system reduces hormone production to conserve oxygen. Nope, that's not what we annotated. The skeletal system releases calcium to fuel ATP production. No, definitely 2 here, not even a question. All right, finally, describe how 3 body systems work together during exercise to produce enough energy and prevent bone loss. This question is bringing it all together. you need to talk about energy production, bone loss, and our 3 body systems. So we're going to make a checklist. All right, and this question's asking us to describe how, so we need to give details about this. First off, our 3 body systems, we already annotated them in our reading. They are respiratory, circulatory, and muscular are the 3 mentioned in our reading. And then, of course, 4, we're talking about bones, so we're talking about skeletal system. We can include any 3 of these 4. Energy production. What does this mean? Energy, that's ATP. So we're talking about ATP production. How do we make ATP? Cellular respiration. Finally, preventing bone loss. This happens through osteoblasts. Okay, so we're putting all of this together in a descriptive response. We're including what systems are involved, and we're talking about these 2 processes and their involved components that we're going to include here. Okay, so for our final response here, we have during exercise, the respiratory system brings oxygen into the body. The circulatory system then transports the oxygen to mitochondria in order to perform cellular respiration. Cellular respiration produces ATP energy to keep up with the energy demands in the body during exercise. Also during exercise, the muscles in the muscular system contract, which stimulates osteoblast activity in the skeletal system. Osteoblasts build more bone, which prevents bone loss. Okay, so here you see we touched on energy production. Good. We explained what prevents bone loss. Good. We talked about 1, 2, 3, and 4 body systems, and we included details like how osteoblasts work, that this is cellular respiration, where this happens in the body, what the jobs are of each of these systems. And through all of that, we have successfully described how 3 body systems work together to produce enough energy and prevent bone loss. All right, key points here. These clusters are difficult. You need to study, you need to rewatch videos, and you need to practice. Come to office hours if you want more help getting ready for your trimester exam, and have a great rest of your weekend.